Okay, so in this question we are given a uniform electric field of magnitude 325 volt per meter. So let's call this E0. And the electric field is pointing in the negative y direction, and hence there's unit vector j with a negative sign specify that it's pointing in the negative y direction. So in this uniform electric field we need to find the potential difference between 2 points, A and B. Points A and B are specified by their coordinates. So for A it's minus 0.2 and minus 0.3, for B it's 0.4 and 0.5. So the question is, what is the potential difference delta V between these 2 points? Well, in order to calculate the potential difference, we can use the formula that we've introduced in the lecture, which is saying delta V of VB minus VA is equal to the negative of the integral of E dot ds, where ds is the displacement vector, from point A to point B. Now, what is the actual path that you take in order to take this integral doesn't really matter. But the choice of the path can simplify the solution. And so it's suggested in the question to choose this path to solve for delta V. So we first go straight up, let's say to point C, and then to the right from point C to point B. Okay, so this, we can then say that delta V is equal to minus the integral of E dot ds from point A to point C and from point C to point B. Now this can be broken into two integrals. This is equal to negative of integral from point A to point C, E dot ds, minus integral from point C to point B, E dot ds. So this is then equal to, well, let's first look at this from A to C. That is, we're going from here to here. In this part of the path, you can see that the ds vector is actually identical to the dy vector. So we can say that instead of ds, for this integral, we're going to use dy. So this is then equal to, well, let's look at the first integral here, from A to C. From A to C, our displacement ds is actually equal to dy multiplied by unit vector j. So along the path AC, ds is just equal to dyj. So we can say that this is equal to negative E, which is this, E0 minus j time dot dyj. So from A to C minus now this integral from C to B. From C to B, our ds is equal to dx, unit vector I, because it's going along the x direction. So now again we have electric field, which is E0 minus j dot dxi. Well, if we first look at this integral here, we have a j dot I, a dot product of two unit vectors. They're perpendicular, so this integral entirely gives us 0. So we don't need to worry about that. So let's just look at this one. Here we have minus and minus, so they cancel out, and then you have j dot j. Unit dot product of the same unit vector gives us 1. So overall you get E0 is a constant, so it comes out. So E0 dy from A to C. So this is then equal to E0, the y coordinate of point C minus y coordinate of point A. E0 is given, that's 325. Y coordinate of point C. Y coordinate of point C is equal to 0.5. So that's 0.5 minus y coordinate of A, that's minus 0.3. So you get minus 0.3. So overall this gives us 260 volts. So the potential difference between points A and B happens to be 260 volts.